Welcome back. In our last learning target, we talked about compound OR inequalities, where we either had a value going to the left or a value going to the right, a value that was less than or a value that was greater than. In this learning target, we're going to sort of talk about what happens when they meet in the middle and they cover an area together. So we already know what a compound inequality is. Let's look at what happens when A and B is true when both are true. So the key word here is both and the word and. So that means that both A and B have to be true for this truth table to work. So let's take a look. So I've got in the first row, it says that 3 is odd for A. Is that true? Yep. And 4 is even. Is that true? Yes. Now, are A and B true or false? Well, they're both true, so that means that this has to be true. Okay, it only works if both are true. Let's take a look at the next row. This says 3 is odd, that's true, and then it says 4 is odd, that is false. Are both A and B true? No, this is a false, so that doesn't work, so then this has to be false. They have to both work for this truth table to work. For the next row, it says 3 is even, that's false. 4 is even, that is true. Well, because this one is false, then the whole thing is false. Okay, and I'm actually going to use a different color for saying no. So nope, nope. And so because those are false and no, then both can't be false. Okay. This one, 3, the last one, 3 is even, that is going to be false. And 4 is odd, that's also false. Well, neither are true, so definitely both can't be true. Okay. So that's sort of the lens in which we're viewing this relationship. And to put this in words, we can say A and B is true only when both are true. Okay. This type of relationship forms an intersection. So this is the overlapping region. Where both solutions are true. Okay, so what does this look like when it comes to graphing, when it comes to our notation and how we read it out loud? So the notation looks like a little different than probably what you've seen before, where now we have 2 inequality symbols and we've got an X smack dab right in the middle. What this is saying is, if we look at this first one, I'll highlight it here. This is saying that it's all real numbers that are greater than 0 and less than 5. You can also think about it as it's between 0 and 5. Okay, it's between 0 and 5. Now, there are no lines underneath, so when I go to graph it, I'm going to have to use my parentheses, but the graph looks like this, where you've got your just one single line, and it's at either end are what the inequality symbols are. So because we had no lines under either of them, we're going to use parentheses. We could also use an open circle here too. I could have graphed it where I have an open circle on 0 and an open circle on 5, and then the line is all those values in between. It can't be -1, it can't be +6. It's all the values between 0 and 5. And you'll notice in both of these examples, we use less than symbols for this type of relationship. You won't see greater than symbols in your final answer. We always use less than symbols to show something being between. Okay. The second example just says what happens when we have to use brackets. So this is still between now -3 and 2, but it also includes the -3 and then 2. So that's why I would either have brackets, or I could have a closed circle on -3 and 2, and then a line connecting them. Okay, so this is called an intersection. All right. Solving these look a little bit different than what you've solved before. So this is our first couple examples. You'll notice that you've got those 2 inequality symbols, and what you're going to do, same thing we've done in the past, is draw that line over each one of them. Now you're going to solve from the inside out. In fact, let me rewrite that. So we're going to solve from the inside out. What that means is you're going to look at where the variable is, which is in the middle, and you're going to undo what's happening in the middle. In the case of the first example, to undo this 4, division by 4, you're going to multiply every side by 4. So I'm multiplying that middle by 4 because then these cancel out and I'm just left with x. But when I do that, I have to multiply on either side of both lines. That's the new idea here. So I multiply the left side by 4. So I get -4. Bring down my less than signs. On the right side, I get +4. Okay, that is my answer algebraically. Graphically, I'm going to have a parenthesis on -4 and a parenthesis on +4, and I'm just going to connect the two together. You could also use an open circle and an open circle and connect the two together. Okay. Letter B, draw your lines and solve from the inside out. So I'm trying to get x alone, so I'm going to subtract the 3, and I'm going to subtract it on the right, and I'm going to subtract it on the left. The 3's cancel out in the middle. -6 minus 3 on the right is -9. Bring down your less than, bring down that 9x, bring down the less than or equal to, and 48 minus 3 is going to be 45. Last step is to divide the inside by 9, so then the outsides also have to be divided by 9. The 9's cancel, and I'm left with x on the middle. On the left side is -1, and on the right side is 5, carrying down those inequality symbols. Now in this case, this left symbol right here, that doesn't have an equal to sign. So when I draw that symbol, that's going to just be a parenthesis on -1. But the 5, the inequality sign of the 5 does have an equal to sign. So when I make that, I'm going to make it a bracket. And then I'm going to connect the two just like that. Okay. The next example has something tricky. The next example, it starts off the same. Solve from the inside out. So I'm dividing now by -8. Now remember, what happens when we divide by a negative in an inequality? What do we have to do with this sign? Well, when we bring it down, we're going to have to flip it. So this becomes a less than or equal to, and this becomes just a less than. The 8's cancel, left with x in the middle, a 2 on the left, and a +10 on the right. So x is between 2 and -10. Make a parenthesis on the 2, make a bracket on the 10, and connect the two together. And finally, this last example, it's only really tricky because often when students see this number 10, they kind of forget that it's +10, so they sort of forget they have to subtract it first. So I just put this example in to show you would subtract that 10 first on every side. The 10's cancel. 22 minus 10 gives us 12. Bring down your symbol. Bring down that -4n, the symbol, and -12. And now again, because I'm dividing by a negative to everything, I've got to flip these signs. So this becomes a less than or equal to, and this becomes a less than. The 4's cancel out. I'm just left with n in the middle, using a fun new letter here instead of x. That's okay. -12 divided by -4 gives me 3, and 12 divided by -4 gives me -3. Put that bracket on -3 on the left, parentheses on 3 on the right, and connect the two in the middle. Okay. In a lot of ways, I think compound and inequalities are a lot simpler than compound or you're dealing sort of with just one inequality instead of two in a way. But that's your call on what you think is easier or harder. The last thing you'll be able to do, like in the last learning target, is look at a graph and be able to write the inequality. Like I said, you're always going to be using less than, so I always start off like this for each problem, and then I add to it. So this left one here, that has a bracket, so I'm going to have to put a line underneath. This right one here does not have a bracket, so I'm going to leave it the way it is. So this is a less than, this would be a less than or equal to. And then the numbers I'm using are -4 and +3. The other example, x in the middle, use less than symbols to start. For -1, I'm going to leave it as a less than because that doesn't have a bracket. And on the right, 5 is a less than or greater than. So I need to put a line underneath there and put a 5 here. Okay. That's it for our compound inequalities and for the unit. So good luck on your practice. And as always, please ask for help if you need it.